design systems will be a software package that helps engineers achieve safer and more optimized design in shorter time span. Engineering design typically has two phases: architectural design and structural design. Architectural design is essentially the schematic design of a structure, the visual appearance. On the other hand, the structural design involves advanced knowledge of mathematics and mechanics of material to calculate required dimensions of structural components, such as beams and columns, based on the loads applied to the structure, which can be wind, earthquake, and gravity loads. A structural design can be subdivided into two steps: analysis and design. Engineering analysis are mainly done by numerical methods, such as the finite element method. Once the analysis is done, the next step is to verify that the proposed structural solution that complies with the applicable building design codes in order to achieve target safety levels. In essence, the design codes are a series of criteria which allow engineers to ensure that the building design targets acceptable safety levels. However, these codes are a minimal requirement and do not have to be followed step by step if one can demonstrate that an alternative design is acceptably safe. Such a reliability-based design is the area of expertise of my co-founder, Dr. Fenton. He is a professor in the Department of Engineering Mathematics and Department of Civil and Resource Engineering. His papers have more than 7,000 citations. Dr. Fenton has published more than 150 peer-reviewed papers in the field of risk assessment. Dr. Fenton is also co-developer with Dr. Griffiths of the random finite element method, which is both a theoretical methodology as well as an accompanying suite of computer programs which estimate the reliability of geotechnical systems by combining random field with the finite element method. My name is Reza Rahimi. I am a PhD candidate in the Department of Civil and Resource Engineering at Dalhousie University. I have experience in designing structure both in Canada and overseas. During my PhD program, I have been working on accelerating the design process of masonry structures, which can be expanded to other structural components as well. I have published 5 peer-reviewed papers in this field. In the construction world, between 10 to 20% of the budget for each project will be spent on the design. For instance, the design cost of the Emera Idea Hub here at Sexton campus was roughly $10 million. Consulting engineering companies typically enter bidding competition for projects using the most optimal design that they have been able to determine in the competition. Therefore, these companies are always in search for faster, more accurate, and reasonably priced software to increase their chance at winning design bids. Our target consumers would be consulting engineering companies. There are more than 1,000 companies here in Canada, all of which are currently customers of software companies in the US and in Europe. Our primary competitors are ANSYS, Dassault Systems, Bentley Systems, and etc., all of which are non-Canadian and multi-million-dollar operations. But how will we stand out in the competition? We offer similar finite element analysis, but faster, since we use advanced computer hardware and support for cloud computing. We will use risk assessment concept to decide on the optimal design, based on over 30 years of experience of my co-founder, Dr. Fenton. We will use advanced machine learning algorithms to let the computer suggest optimal solutions that improves with experience. We will develop civil engineering structure and geotechnical finite element programs that runs in excess of 100 times faster than the usual finite element programs can run on a single CPU. We also plan on running our finite element programs on cloud. This means that consulting engineering companies do not need to have access to powerful computing hardware devices themselves. We will provide both the code and the fast computing environment. We envisage that engineers will soon be able to use our sophisticated software to produce risk-based civil engineering design using as little as their cell phones. Competitive software packages generally involve running repetitive finite element analysis and checking the result of each trial design solution against design code to see if the proposed design is safe or not. There is no guarantee that a proposed safe design achieved by this iterative process is anywhere close to an optimal solution and often result in over-conservative designs. Also, in some cases, for example, in geotechnical engineering, there is no design code available for certain problems, and engineers have to rely on their engineering judgment, which often ends up in an over-conservative design. Over-conservative designs increase construction and lifetime costs and reduce the chance of consulting engineering companies winning a project bid. Our software will allow the smart selection of near-optimal designs through our huge speed-up of individual finite element analysis and the consequent ability to search through a wide variety of design alternatives for the risk-based optimum. Risk-based design search for the design having the lowest expected total project cost, which includes consideration of the cost of failure. For example, hospitals and schools must result in safer designs than storage sheds because of the significantly higher cost of failure of the former. The revenue model chosen has two main streams, charging per use and charging monthly. The revenue model was validated during the customer discovery. The pricing structure intended for consulting engineering companies is the combination of low-cost annual license and pricing per project, while universities will have an annual subscription. Indeed, companies are interested in the pricing per project method. This pricing structure would provide a freedom for companies to use and pay for the software only when there is a need. This made sense to the companies as sometimes they are billed for softwares that they are not using. In pricing per project, the companies will be billed based on the size of the project and based on the numbers of engineers working on the project. This kind of pricing is only available through cloud computing, which is one of the reasons we would go with this type of licensing. The other advantages to the customers of using this price per project via cloud computing approach are accessibility to powerful computing without needing to invest in expensive equipment, complete flexibility for the users since they can connect from virtually anywhere in the world and no need to install or update software. Smart Design Systems was first mentored by the Norman Newman Center of Entrepreneurship at Dalhousie. We have used the business model canvas to form and test our business model. At this stage, we have focused on customer discovery segment of the canvas. We have interviewed companies, universities, and individual engineers to evaluate our ideas. 2 major companies and 1 university here in Halifax have agreed to test our software, and they will become customer if we deliver what we promise. We will continue the customer discovery and evolve the solution based on customer demands. We anticipate that our software would be purchased by civil engineering companies worldwide. We believe that our risk-based solution, along with the fast computational ability of our software, will set us well ahead of our competition. Smart Design System is a software package that built by engineers for engineers. Thank you for watching.